to draw polyatomic ions, like your those annoying like hypochlorite and perchlorate, those sort of things, sulfate. Lewis structures are kind of stick structures and that sort of thing. Lewis structures show sigma bonds. If it's a double or triple bond, of course, then it has a pi or 2 pi's, respectively, covalent bonds. Each time you see a dash, that means 2 electrons are there being shared. Lewis structures also show lone pair electrons. So if you found number 14, experiment 14 in your lab manuals, okay, then we should be kind of set. It gives you some information about tips to drawing the Lewis structures. And then if you actually turn to your, we're just going to kind of jump in there. We might be referring to those tips. But if you jump into your first sheet that looks kind of like this, it has 2 columns. And it has 1 through 5, steps 1 through 5. Okay, each column is there for you to do a Lewis structure. Okay, so that's the plan for today. Actually, we're going to do 4 columns or 4 Lewis structures together, and then you're going to make I have little boxes of little model kits over there for you guys to make them. Okay, so we might, Austin, who's usually your part? Are you usually partnering with them? Okay, we might just have you scoot down, and do you know Alicia? Alicia, Austin, your names both start with the letter A. Hello. Okay, so we might do that today. And if you want to work by yourself or work with these guys, you sure can. Okay, Colin? Okay, sometimes the whole collective mind kind of makes it work. Okay, so let's just step through it, and we'll kind of go from there. So instead of like, what do I say, horizontally, I've actually kind of made these vertically. So I don't know if that works for you. So instead of like, you have step 1, step 2 and 3, step 4, step 5, and I have made them columns. Okay, so hopefully you can translate that okay. So step 1 is pot of valence electrons. That works, okay? Step 2 is actually kind of that initial arrangement of the atoms, and we'll draw in that initial covalent bond, pair of electrons, okay? That's step 2 and 3. Step 4 is actually, we're going to look at our pot, and we're going to see what we have left over. And kind of like I did in lecture, I told you we're going to actually, what we have left over from our pot after our initial structure, we're going to distribute them around the outside atoms first. Those are called terminal atoms. That's step 4. And step 5 says we finally turn our attention to the middle atom, and if it doesn't have 8 electrons, we're going to go ahead and swing lone pair electrons in to make a pi bond. Okay, so let's see how that works. So we're going to do 4 together. And then we're going to have checks at the bottom, okay? So our checks go something like this. We are going to check if on our final Lewis structure, if we did go ahead and if on our final Lewis structure, did we go ahead and use the pot of valence electrons that we should have? That's our first check. The second check is, do all atoms have a rare gas configuration? Now, how many times does hydrogen want to reach out, and how many electrons does it want? Hydrogen, remember? Wants to reach out once, yep. And then how many electrons does it have if it reaches out once?
2.
It has 2 electrons, right. And with 2 electrons, it's like helium, actually. So it does have a rare gas. It doesn't get an octet. So hydrogen's like that. And then this last check only applies to if we're doing the Lewis structure of a neutral molecule, which won't always be the case. But we said if it's a neutral molecule, then you can look at the atom, and it should reach out a number of times. It's 8 minus the group number. That's the expected valence. Okay, and then at the bottom, actually in green here, I've got for each structure, you're not quite done, you're almost done. Then you need to actually, one of your homework questions says, look at the central atom and answer these questions in green. Okay, and actually this board right here is going to help us answer those questions. So we said if you want to know what we call the structural geometry, if you want to know the structural geometry around an atom, what you do is you put on blinders, look at that atom, you count lone pair electrons, dots around that atom, and sigma bonds. If it's 2, then you go with this row. Okay, if your lone pair electrons and sigma bonds add up to 3, this row. Okay, 4, this row. Okay, so let's see how that works. So we're going to do, so at the top, go ahead and write NH3. NH3. Like bingo. Okay, and if you want to go ahead, and sometimes students like to do this with me, and sometimes they kind of take out on their own a little bit. But pot of valence electrons. Now you need a periodic table. So you've got a periodic table in your, either up there or, yeah, in your red, you know. Hey. So there you go, Colin, you're not alone. So we're on 14, did we decide? Tyler?
Yeah.
Okay. So your pot of valence electrons, there's one nitrogen atom, and I usually do it this. I do N, that's my element. There's one nitrogen atom, and then I use the periodic table to see that it is in 5A, so I write 5 electrons next to it. That's just for nitrogen. Then I go to hydrogen. There are 3 hydrogens, and they all bring 1 valence electron each. So 3 times 1 is 3. Okay. Then I add my 5 plus my 3, obviously, and I get 8. So that is my pot of valence electrons. And again, I get that off of the periodic table. Well, I get it from the chemical formula, you know, what elements are involved and how many there are. And so that's my pot. Okay, so that's step 1. Now, we said that actually you need to, in today's lab, you're going to put something in the middle. Okay, and that something in the middle, I don't know if you remember, but it's going to have be the lowest electronegative. So your choices are, do we put nitrogen or hydrogen in the middle? How many people think we put nitrogen in the middle? I do. Yeah. Does hydrogen ever want to be in the middle? No. Don't make it. So all that means then is your next kind of step looks like this, with a nitrogen in the middle, and the 3 hydrogens scooting out from the nitrogen. Now remember we talked about sigma bonds, the primary bond, and the other bond, pi bonds, the secondary bond. Sigma bonds are the first to arrive. At this step, you have drawn sigma bonds. Okay, how many electrons are in each one of these dashes? 2, yep. So actually that goes for my step 4. So how many electrons do we have here? 6, exactly. So 8 minus 6 is 2, okay? So that's my 8, goodness, I can't read my own writing. Yes, that's my 8 minus 6, that's 2 electrons. So we're going to have to put those somewhere, and we're going to do it strategically to work towards octets. Okay, so nitrogen, it only has 6, it wants 2 more. So, you know, we're just going to put those 2 electrons around the nitrogen.
That's still step 4.
Yes, that's step 4. Yeah, that's step 4. So now we have nitrogen, sigma bond hydrogen, sigma bond hydrogen, sigma bond hydrogen, and now we have the 2 lone pairs there. So, step 5. You don't always have to do step 5. Sometimes it'll be not applicable, Na. So, if the central atom does not have a complete octet, does the nitrogen, which is the central atom, does it have a complete octet now? Yeah. So, in step 5, just put Na. Na. So, let's see. Total electrons in this structure. How many electrons do we have in this final Lewis structure?
8.
We have 8. So go ahead and put an 8 there. Oops, do I have? All right. Okay, does each atom have a rare gas configuration? Does octet?
Yes.
Yes. Nitrogen has an octet, and hydrogen has a duet, which is like helium. So yes, check mark there. The last one, is this a neutral molecule? Is it a neutral molecule? Yes, it is a neutral molecule because there's no charge up in the upper right-hand corner. So since it's neutral, then it should follow the valence rules. How many times did we say hydrogen should reach out? Just once, and it's following the rule there. Nitrogen is you find it on the periodic table. Find nitrogen on the periodic table. Yep, it's 5. So 8 minus 5 is 3. So nitrogen should reach out 3 times. Is it reaching out 3 times? Sigma and pi bonds. Yes. So that's awesome. It is. Okay, very good. Then the last 3 things at the bottom of your column. Now these only apply to, any of this stuff only applies to an atom. It's not to the whole molecule, it's to a given atom. And now we're focusing on nitrogen. So how many, around the nitrogen atom, how many sigma bonds? 3. Around the nitrogen?
Sigma,
Yeah, 3 sigma bonds. Around the nitrogen, so that's this. Okay, 3 sigma bonds. Around the nitrogen atom, how many pairs of lone pair electrons? How many pairs of lone pair electrons? 1, yes. 3 plus 1. So I'm liking 4 for this one. Does that make sense? Ooh, that's great. Okay. So then you can answer all of those questions. Orbital hybridization, sp3, geometry, tetrahedral, bond angle 109.5, which is not a radio station. I used to say, well, that sounds like a great radio station. This thing that's on the board, by the way, is actually, if you look kind of before these what we're doing now, it's in your, it's in a slide. So if you kind of flip back, it's in a slide. Any questions about that? So the whole point of you making your cute little molecules with your sticks and stuff, does it look nice and tetrahedral? It kind of, to me, looks tetrahedral from what I see. Okay, let's do another one. And we'll kind of pick up speed probably as we do these. Okay, so all I did is just kind of copy the blah, blah, blahs. Okay. Now, so at the top, go ahead and say, we are going to do, which one are we doing? Drum roll. H2CO.
You're missing the CO.
I am. H2, 2 hydrogens, 1 carbon, 1 oxygen. So in the first step there, you can see on my slide, or you can do it on your own too. The first step, the pot of valence electrons. Hydrogen, carbon, and oxygen. Hydrogen is equal to 2 times 1 electron each. Carbon is equal to 1, and it's a 4A times 4 electrons. And oxygen is equal to 1 times 6, because it's 6A. This is one of those things in chemistry where there is kind of a little algorithm out there. Okay, so we all, I think it looks like we're pretty good. 12 pot of 12 valence electrons. Maybe that's right. Yeah, there's only 2. There's 2. Oh, wait a minute, yeah. So there's, oh, okay, so you separate out, that's cool. So there's 1, so there'd be 1 here, and this is 1, and 1 there. Yeah, 1 and 4, that's good, and then 1 and 6, that's good. So then if you add up 1 plus 1 plus 4 plus 6, you get 12. Okay, so now the next step, so we're not going to put hydrogen in the middle, and then our choices are carbon and oxygen, and fortunate for us, they actually are in the same period. So we want the lower electronegative of the two. So which one is that? It is carbon. Yep, lower electronegative is over here on the left. So we're going to put carbon in the middle and scatter the other 3 atoms, which is the hydrogen, the 2 hydrogens, and the oxygen. So right now that's our preliminary Lewis structure. So we have a middle carbon atom, sigma bond hydrogen, sigma bond hydrogen, sigma bond oxygen. So how many electrons do we have there so far? 6. Yep. So 12 minus 6 is 6. Yep. So we have 6 electrons to do something with. Now we're going to put them around the terminal atoms. Are we going to put any more electrons around hydrogens? No. Hydrogens are done. But now we need to focus on the oxygen. So how many more electrons does oxygen need? It's got 2 now. So how many more does it need to get octet? Yep. It needs 6. So it's going to hog all of those. So the next structure in the next box is going to put the carbon, sigma bond hydrogen, single bond hydrogen, okay, and then single bond oxygen with those in pairs, dot, 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 dot. So what we say, 3 lone pairs of electrons. I love the term lone pairs. Does that look okay? Okay, so the last step actually is applicable this time. I'm so excited. So because your carbon atom, how many electrons does it have right now? It only has 6, and it wants 8. So we can do that by swinging basically one of these pairs in and making a pi bond. Okay? So when we do that, the oxygen still has it, and now it shares it with the carbon. And we talked yesterday about resonance structures. And if we look at these as kind of the north, south, and east pairs, we could actually make 3 different resonance structures. That's so exciting, okay? No, we couldn't. No, that's from a different atom. So I take that back. We cannot, there's no resonance structures here. Mental block, mental block. Okay, so I happen to swing from the north, which is fine. It wouldn't have made a new structure if I had swung from the east or the south. So I take that back. All right, so in the last one, here we go. We write our rehashed or remixed Lewis structure. And now instead of just a sigma bond, we have a double bond, sigma and a pi bond, because we swung a pair of electrons in from the oxygen. It's wonderful. Okay, so I'll give you a minute. Go ahead and make that Lewis structure. So if we've used 2 electrons, then 10 minus 2 is 8, right? So we have 8 to do something with. Now just for kicks, kind of the left-right nitrogen, I'm going to go with the right nitrogen is the central nitrogen, and the left nitrogen is the terminal nitrogen, and you'll kind of see why. So we always say fix your terminal first. So my next step, step 4, is to go ahead, and how many electrons do I need to put around that left nitrogen to give it 8? I need to put 6, that's right. So my preliminary structure then looks like this, where I have nitrogen, sigma bond nitrogen. You told me 6 electrons, they come in pairs, so I have dot, 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 dot around the left nitrogen. And then as it turns out, that's 6 of my remaining, and so I have 2 more. So I go ahead and start making this guy happy anyway. So I put my other 2 electrons around my central nitrogen. Awesome. Now we're ready for this step over here, step 5, the last step. So how many, we went ahead and gave the left nitrogen a complete octet, but the right nitrogen, how many electrons does it have? This guy right here. It only has 4, and so it needs 4 more. Yeah. So honestly, here, we're going to have to go ahead and rob, not robbing because they're being shared. We're going to have to swing these in, make a pi bond, swing these in, make another pi bond. We have a triple bond there then. Did you see that game last night? I don't know if y'all are Cubs fans, but oh my gosh.
I'm not even a Cubs fan, and I was like,
that's so exciting. The rain delay, my husband's like, I don't know if I can do this, but then it was short. So I loved it. I feel a little bad for the Indians though, I don't know. But Carl's like, yeah, they can't all win. So anyway, so triple bond. So we rewrite this structure in the box 5. We have nitrogen, triple bond nitrogen, and we had a pair of electrons that we didn't swing, and we had on our left one, and we had a pair of electrons that was already there on our right one. So go ahead and make that structure. What do we have over here? 10. So that check is great. Do they both nitrogens have an octet? Yep. So there's my little Venn diagrams. They both have an octet. Is it a neutral molecule, right? So expected valence of a nitrogen atom, what is it? group number 5, how do you get the expected valence?
Subtract from 8.
Yes, you subtract
8
5
minus
from
group
8.
number.
Yep, 8 minus the group number. So 3. Is it reaching out 3 times? Yeah, so that's cool. Okay, so we're going with, this is very symmetrical, but we're going with this nitrogen atom right here, right? How many sigma bonds is that nitrogen?
3. No, sigma 1.
Sigma, 1, very good. How many pairs of lone pair electrons?
2.
How many
One
pairs?
pair.
1, just 1 pair, 1 electron domain, yep. So we have 1 plus 1. What's that?
I said for each atom, because I said there's 2 pairs of.
Yeah, but we just focus on 1 atom. So from that atom, we have 1 pair around that atom. Yep, so 1 plus 1 is 2. So we're all about this then. Okay? Since it's 2. Okay, we're all about the whole sp orbital hybridization. The shape is linear. And hopefully you can kind of see that linear. If you take that triple bond, kind of squish it together, does it kind of look linear, I think. They're pretty rugged. Now the last thing, if you put 180, which I did, that's great. Actually, it could be an Na again, either Na or, okay. One more. Good job, guys. One more. Un mas together, and then I'm going to turn you loose. This last one we're going to do together is, dun, dun, dun. I can't remember. Which one is it? Maybe I didn't. Did we do 4?
Yeah.
Oh, we're not doing any more then. Okay.